The key challenge with Bahrain and those temperatures is just not to get misled by the big swings between the hot sessions and the cooler, more representative sessions. So with the race being late in the day, the sun's gone down by the time it starts and everything's cooled down. And those create quite different conditions for the car and the tyres. When we look at the approach to the free practice session, we're trying to maximise our learning for the race in the sessions that are actually appropriate at the right temperature. The P2 session, where you can really focus on your race programme. And then there's a question of what do you do with FP1, what do you do with FP3? They're much hotter. They're in the middle of the day and you're getting track temperatures that can be anywhere up to 50 degrees C, but certainly normally north of 40 degrees C. Now in FP1, we might look at some test items because you can take advantage of those really hot conditions. It's quite aggressive on the tyres, and look at work to try and understand degradation, rear overheating, all of those factors, and the conditions are good for that. FP3, you'd be focusing on single lap, you'd be doing a lot of cooling down to try and get the tyres back to a sensible temperature to start the lap. And then you're also looking at how you can offset the effects on the car. So understand what your balance is in FP3 and then look at how you can correct that to make sure you've got the right balance in the cooler track in qualifying.
This time next week we'll all be in Bahrain trying to run our Formula 1 car, and that brings about some fairly specific difficulties with the high temperatures that we expect to see there. We have different cooling systems on the car. Largest among them in terms of its impact on the design of the car is the power unit. The power unit cooling in general is driven by the air inlet, so the air enters left and right through these ducts primarily, and the bulk of the mass flow for the cooling then comes through the side pod and exits at the rear of the car. And then we also have the roll hoop, which is primarily engine inlet air for combustion, but also we have some centerline cooling. Talking through on this side of the car where we've got the bodywork removed and some of the car cut away, we can see more clearly that the vast impact that the cooling layout has on the overall shape of the car. The power unit and the central part of the car, the fuel cell and the survival cell are quite small, and then the radiators stick out from there. The air inlet is here, and so the air then expands out over this entire area and passes through the radiator, past the fins, and cooling in that short period of time that we are in contact with it, so the radiator is in contact with the air. And you can see, if we look at the radiator, that there's a front core here and then there's a rearward core there, so there's actually two radiators each side stacked on top of each other. And because of the nature of the power unit and our requirement for fluids at different temperatures, we take off different amounts of water and fluids at different points around the radiators. The other aspect that we can now see on this side of the car more clearly is the complexity of the centre line. This is the air inlet to the engine, so the air that's for combustion, and then this is the two ducts at the side of the roll hoop, which go down and divide into the gearbox cooler and some additional water cooling.
One of the other challenges with Bahrain that affects the start of any session is actually there's so much sand around in the area. It's normally quite windy there, and all that sand gets blown on when the cars aren't running. And that can give you quite a big offset at start of session. So no one really wants to be first car out. It then becomes a bit of a standoff where everyone's waiting for someone else to go and clean the track. And that's also quite an issue in qualifying, because if you're only wanting to do one run in a session, you want to do it when the track's in good condition. By the time we've seen sort of 20 cars go by or something, it starts to get back into a more sensible region. But it is just one of those Bahrain specific things that we need to think about. Even during the race itself, the track's still cooling down, so it's got the heat that it's stored up during the day. And you might get another 5-6 degrees even of cooling during the race. And that does make life just a bit easier for the rear tyres in the final stint. You may even get a bit of understeer creeping in. But these are the things that we're watching during the weekend and just trying to make sure we're keeping the car in the right region, trying to get the most out of the car and the tyres.
The airflow that passes through the car is a parasitic loss. We'd like not to have it in qualifying, however we need it for the race. As it exits, the more mass flow that passes through the car and the more mass flow that we have to use for cooling as it exits the car, we lose aerodynamic performance, both as drag and also as a disturbed flow around the rear wing and the diffuser of the car. The rules of the sport are such that we have to carry the same cooling in qualifying to the race. So we always start the race with the same cooling configuration that we've used in qualifying, the same radiators and therefore the same mass of water on the cars, and we are therefore very reluctant to run the car too closed up in qualifying because we might be stuck in traffic on Sunday. At every race we go to, we try and shut the car down as much as possible, minimise the airflow through the radiators so that we provide just enough power unit cooling to make the race painless, but not to overcool the car, as that will cost us qualifying performance. If we open up the car too much, we can lose tenths of a second in qualifying, and that's extremely painful. But if we can shut down the airflow through the radiators, that alone is aerodynamically worth several tenths of a second in lap time. There are also considerations which mean that the power output from the engine can be affected adversely if we get the fluids in the wrong region. So actually, strangely enough, we will be faster in qualifying if we can warm the car up more, and again faster in the race if we can get the water and oil at the right temperatures. If we have got the cooling wrong, we have been known to take the precaution in race pit stops of opening up this area. We can shut down these louvers externally, and then that becomes removable in a pit stop, and that's entirely within the regulations.
A number of years ago, a lot of people were noticing that there were some tracks where Mercedes were going very well and others that we were quite poor. And we've been looking into those problems. What we started to notice was actually the races where we were good were the ones where we were having a lot of curry, going out to have an Indian before the race, for instance, on Sunday. And the ones where we were bad, they were the countries where that was more challenging. So one of the problems with Bahrain is the offset schedule. You can find curry houses there's plenty in Manama, but finding one that's open at sort of 11 o'clock at night, that's quite a challenge. So we're also doing a bit of work on that behind the scenes, making sure that all of those sort of preparations are lined up so we can hopefully have a straightforward weekend.